In the following figure, a block with initial velocity v0 slides from a smooth horizontal track into a smooth vertical circular track with radius r. However, the block did not make it to the top of the track and fell off the track at a height h greater than r and less than 2r. What is this height? So I'm going to start by drawing a sort of free body diagram for it. So if I draw a big circle here, let's say that the object is here when it falls. Remember, this is the radius r, which is the same here, and the diameter, or the whole length here, is 2r. So the height is greater than r and less than 2r. So it's somewhere along this arc when it falls off. So let's say it falls off here. When it's falling off, you're going to have the force of gravity. If I try to draw this, mg acting down. And when it's undergoing circular motion, you have the normal force pointing towards the center of the circle. I'm going to say that the radial direction towards the center of the circle is the positive x direction, and the tangential direction in the velocity direction is going to be the positive y-axis. So we can decompose gravity into a tangential component. So I'm going to actually move this inside. Decompose gravity into a tangential component and a radial component pointing towards the center of the circle. So these two will form a right angle. And now if I make an angle here towards the object and call this theta, then this radius will be perpendicular to this tangent line here. So this is 90 minus theta, and so this angle here is theta. So the force in the radial direction becomes mg sine theta, and the force in the tangential direction becomes mg cosine theta. And now we can apply Newton's laws to help us solve this. So we know that mg sine theta plus the normal force must be equal to the mass times the centripetal or radial acceleration, which is equal to v squared over r. And in this case, when the block falls off, the block will fall off when the normal force is equal to 0 newtons. So if this is equal to 0, then mg sine theta must equal mv squared over r. Masses cancel. You get that g sine theta is equal to v squared over r. So v squared is equal to gr sine theta. And we actually don't need to square root this velocity. And we'll see why in a moment. So we just need to remember our end result from this whole thing. And I'll erase this diagram here. So remember that v squared, when it's falling off, the velocity squared is going to be equal to gr sine theta, where theta is the angle before it falls off. So that's the first part. So we need to figure out what this is. So I'm going to draw another diagram. So let's say we have a circle, and this is the radius r. And let's say that the object makes some angle theta, same as before. Then the vertical component of this triangle, this is given by r times the sine of theta, and this is r times the cosine of theta. But let's say that this segment is r times the sine of theta, and you have another segment here, which is the radius r. And so the total height, this will be the total height. This will be the height of the object. So if I rewrite this, the height of the object is equal to the radius. It's equal to the radius plus the radius times the sine of the angle theta here. And this becomes the radius times 1 plus the sine of the angle theta when the block falls off. I'm going to try to write this. I'm going to try to write this further in. So the height is equal to the radius plus r sine theta, which is equal to r times 1 plus sine theta, where theta is the angle before it falls off. And again, this was from the diagram I drew earlier. So we can also use energy conservation to say the initial kinetic energy must be equal to the final kinetic energy plus whatever gravitational potential energy it has when it falls off. And this is because the track is smooth. So this implies that the track is frictionless. So there are like no losses to heat and other forms. So the energy is purely converted into gravitational potential energy. So from this, you can say that 1/2 m v naught squared, v naught is the initial velocity, must be equal to 1/2 mv squared, where v squared is the final velocity, plus the gravitational potential energy, which is mgh. And we can actually substitute this in for h. So, and the masses cancel as well. So 1/2 v naught squared is equal to 1/2 v squared plus gr times 1 plus sine theta. And we need to figure out what r sine theta is so that we can plug it back into here. Because while we can just find the equation for the height directly from this, we can't have it in terms of the angle theta because we don't know what the angle theta is. So we can also substitute this v squared directly in. And I didn't square root this so that we can substitute this directly into this kinetic energy equation here. So 1/2 v naught squared is equal to 1/2 gr sine theta plus gr times 1 plus the sine of the angle theta when it is just about to fall. And we need to solve for one of the r sine thetas here. So let's start solving for that. So if we multiply both of these, 1/2 v naught squared is equal to 1/2 gr sine theta plus gr plus gr sine theta. And this is what we get after we distribute here. So we can add these two terms together because they are the same, basically. So 1/2 v naught squared is equal to 3 gr sine theta over 2 plus gr. So I'm going to erase this to make more room. So we have that. Get rid of that. And then now we just simply need to solve for r sine theta. So 1/2 v naught squared plus gr is equal to 3 over 2 gr sine theta. And so multiply both sides by 2. V naught squared plus 2gr is equal to 3gr sine theta. And so V naught squared over 3g plus 2/3 r, 2r over 3, because, again, these two g's cancel, is equal to r sine theta. So that is our expression for r sine theta. So now we can plug this back in to our original equation up here. So the height is equal to the radius r plus r sine theta, which we found to be v naught squared over 3g plus 2/3 r. And again, we can add these together to get that the height is going to, wait. Oh yeah, sorry, I made a sign mistake here. This should actually be minus gr. So all of this is actually minus, not plus. So there was a little sign mistake. So when you're solving these problems, be careful, because you might get it incorrect because of simple algebraic mistakes. And so you can subtract these two, and you get that the height is equal to v naught squared over 3g plus 1/3 r, or the radius divided by 3. And that is the height of the block. And this is how you would solve this problem here.